Hello, everyone that's seeing us right now at Tech Community Day 2020. Today's session it's from Aiko Klostermann, and I will let actually Alvin to introduce Aiko in just one moment. My name is Marcos Cano, and I will be just assisting backstage.
Thanks, Marco. So, as you said, today we want to have Aiko Klostermann. He's a technology consultant at ThoughtWorks. We will present him today an artificial intelligence talk about artificial intelligence, or more like artificial stupidity. So, next. The event today is presented by SQL Server User Group Guatemala, Microsoft Dev Group Coban, Docker Guatemala, and Kubernetes Guatemala, a CNCF group. You can follow us in our social media. There is Facebook, Twitter, YouTube, our webpage. You can also scan us in the QR code, and that will redirect you to our webpage. Next one. Thank you. So as technical assistants, please, if you have any question or any doubt about this talk, you can write it in the comments section. Even if it's in Spanish, we can handle to translate it for our speaker. And we recommend to expand your view to full window so you can watch the entire session with any problem. And please also follow us in Slack. There is a channel where you can make any question that you have for our speakers today, probably, and even tomorrow. So yeah, let's start it.
First of all, thanks for having me. Hello, everyone. And I just heard it's lunchtime dinner time in Guatemala. I must say, living in Singapore, I just woke up on a Saturday morning. But enough chit-chat. Let's talk a little bit about artificial stupidity, or what other people call artificial intelligence. And what I'll be presenting today is I'll be telling you a couple of stories. I'll be telling you stories about machine learning, about ML, about AI, and about data. And some of those stories are success stories, but some of them are not. Some of them have failed, and we'll dig a little bit deeper into those that have failed and see why they failed, and what we can do in the future to prevent them from failing again. And when I talk about telling you stories, let's start with one of the greatest storytellers that we have, which is obviously Douglas Adams. And I'm sure a lot of you have read this book, The Hitchhiker's Guide to the Galaxy. That has brought us a couple of famous memes like that. 42 is the answer to the question of life, the universe, and everything, and that we shouldn't panic. But it also has brought us something that is a little bit less famous. And which is this Babel fish. And for the people who are unaware of the Babel fish, this is this fictitious fish that lives in the Douglas Adams universe. And what it does is, it's this tiny fish, and if you put that into your ear, it automatically translates every language that you hear into a language that you understand, which is absolutely crazy, right? It's fictitious, and obviously that wouldn't work unless, and let's have a little demo. Wow, okay, like sharing this demo is difficult now. What I've done here is I've basically spoken, I've clicked this button and I've spoken in German. Hallo zusammen, lasst uns alle über die Voreingenommenheit der künstlichen Intelligenz sprechen. And what Google Translate, and I'm sure you all have used that, what Google Translate did is it translated that into English, right? Which is similar to this Babel fish, this fictitious, this unimaginable. We are now doing that with technology. I mean, now you're saying, okay, it's not as cool as having a tiny yellow fish in your ear. But apart from that, it is somewhat working the same way. And if I now tell you that Google is selling these tiny fish, they call it wireless earbuds, but basically these Pixel buds do exactly that. Like you You still need a phone, and it's not a living creature, but the idea is that you can put that into your ear. Someone speaks in a language that you don't understand, and the machine learning and the AI inside your phone or the earbuds translate it directly into a language that you do understand. So I think that is one of the examples where machine learning and AI have enabled us and have given us solutions that were like unimaginable and basically seemed not doable some time ago. And I think that's a great example where AI has been successful. And I think there's another example that I really like. There are countless examples. I'm just giving you a few here. The cancer research is a relatively interesting topic for machine learning applications. And there's one thing that a couple of years ago, machine learning algorithms started to predict cancer based on imagery better than human doctors. And that is the breast cancer was one of the first successful cases where machine learning was able to predict breast cancer better than humans. And I think last year, Google released a machine learning model that is able to detect lung cancer based on these images that we see here better than human doctors. And I think we can say that is literally, like, that is a life-changing feature, that the life-changing solution that we are now are able to use machine learning for. But as you can guess from the a little bit clickbaity title about artificial stupidity, there clearly are also cases where machine learning and AI does not work, right? If you look here on the right side, there's this passenger, this Indigo passenger, which is an Indian airline, and he's complaining about that he flew to Kolkata and his baggage landed in Hyderabad. And he's using the sarcastic tone here, and the Indigo, and I assume that is some kind of chatbot or AI in the background, didn't recognize the sarcasm and just says, hey, I'm glad to hear that. And in the middle, there's a similar case where someone is talking to the PayPal chatbot and says, hey, I got scammed. And PayPal's reaction is, hey, that's great. Great to hear that. So there are a couple of cases where AI fails. And this is probably one of my favorite cases where AI and machine learning has failed. And if you know Mandarin, you could already figure it out what's written there. For everyone else, I'm giving a little bit background about what happened here. So there are, in a couple of cities in China, there are cameras installed across pedestrian crossings across streets, like these zebra crossings. And what these cameras do is they point across the street, and they see if someone is crossing the street when there's a red light. They see when someone is jaywalking. And not only do they see that, they also figure out, hey, look, there's a head. They have some image recognition going on. And then they have like a big screen on the side next to it where they just show that person and say, hey, this person just jaywalked. And you can, this is basically the screen that you see here. And then they zoom in on the face. So they try to shame you into not doing that anymore. And in fact, some other cities go even a little bit further. Some other cities have connected this system to a face recognition system. So they not only know, hey, this is a person, this is a face, they also know who you are. And they know who you are, and due to that, they know what your WeChat Pay account is, and they immediately deduct the fine for jaywalking from your WeChat Pay account within seconds. You jaywalk, and 3 seconds later, they immediately deduct the fine, and you get a message, hey, you just jaywalked, this costs this and this much, and we deducted the money already. But if you look closely at this particular example, you see there's not actually a person jaywalking. What you see here is that the camera picked up a bus that was driving, which obviously had green light, And on the side of the bus, there's this face of the person printed. In fact, that's the CEO of a company in China, and they advertise with her on the bus. So what happened here is that the camera picked up the bus, the face recognition, the image recognition, identified, hey, there's a person on it. They identified the person. They shamed her on this big screen. They even sent her a message. At this point, she was in a different city. She got the message, hey, you just crossed the street at a red light. And from a technical perspective, this is a crazy interesting use case, right? Having machine learning, having the image recognition, having face recognition, connecting it to automatically to the financial system, to WeChat Pay, is crazy interesting. But what we also can see here is that it easily fails, right? Like, it's very obvious if you look at the pictures, that's not a real person, it's a bus. Yet the machine learning algorithm was not able to identify that. And what is so crucial about this example is that the implications are here, that we have given this machine learning algorithm so much power that it basically decides whether someone committed a crime or not. And I think that's where we need to be aware of the fact that machine learning can fail, and it can fail dramatically, and that the impact on human life can be quite drastic if we give it this much power. Right, and I've said machine learning and artificial intelligence a lot by now, and we've all heard these terms over the last couple of years. They are quite hyped. I think it is quite important to at least for the scope of this particular talk, to have a common understanding of what these terms actually mean. And let me just start with artificial intelligence, which is, there's this definition from the Oxford dictionaries, which also is, if you Google and say define artificial intelligence, you also get this particular definition. And that definition reads that artificial intelligence is the theory and development of computer systems able to perform tasks normally requiring human intelligence. And the interesting thing to note here is that it is at no point talking about a technical implementation. There's no talk about a technical solution whatsoever. It merely states that artificial intelligence is something where you would think a human needs intelligence to do that, and that is then done being automatically by a machine. To give you a better example to understand that, maybe a chess program. If you think of playing chess, and if you think of a person playing chess, you would assume that person is somewhat intelligent, right? That person knows to play chess, they're somewhat intelligent, and if you now have a chess program that can play chess, you would assume that would fit into this artificial intelligence bucket. It is something where you would require human intelligence, and it's now being done by a program, by a computer. On the implementation side, a chess program, in the easiest way, could be relatively straightforward, right? You look at the chessboard, and you simply brute force all the possible moves that you can do, and then select the set of moves that arrives at the winning state for you. So brute forcing is not particularly smart, right? It's not a genius approach to solving a problem. There are a couple of if-else's maybe. Yet this relatively mundane algorithm, relatively simple, stupid algorithm would fit into this bucket of artificial intelligence. Where it becomes really interesting from my perspective is when we talk about machine learning, which is, as you can see, a subset of the artificial intelligence. But it in fact talks about the implementation of the solution. And it does something drastically different from normal programs, right? Normally the software engineer is just like defining the algorithm, if else, right, loops and all, the control flow statements, which is very different in machine learning. The algorithm to solve the problem is defined by the data itself. A very typical supervised learning approach is you feed in some data and you say, hey, this is the outcome. And then you feed in more data and this is the outcome I want for that data. And over time, the machine learning model learns based on the data, hey, if I get data that is somewhat in this area, this is the output that I need to produce. So that is something where is vastly different from the conventional approach of solving a problem with a computer. And then a subset of this machine learning is a neural network, which is basically just a machine learning model that is inspired by a biological brain, where you have like lots of neurons and they are connected to each other, and there are more neurons, and information gets passed from neuron to neuron, or from neuron layer to neuron layer. And then there's deep learning, which is probably one of the most hyped terms of all of these. And deep learning is basically a neural network, but with a lot of layers. So that's relatively straightforward. And this particular feature of machine learning, that, or especially deep learning, that it has many layers. And if we look here at a deep neural network, is one of the reasons why we have seen those failures in the past, why we have seen machine learning failing so badly. It is simply, and this is an example image of a deep neural network, but the real ones can be significantly larger. You have like a couple of input nodes here, and 3 layers in the middle. Practical machine learning or deep neural networks nowadays have thousands of nodes and 50, 100, maybe hundreds of layers. And all of these are interconnected. And from a human perspective, trying to understand why this machine learning model predicted a certain outcome or resulted in a certain outcome is merely impossible. It's impossible to understand why things happen. There are so many connections, there are so many calculations, so many things depend on the calculations of a previous state, that humans can merely not comprehend why something happened. And that is, as I said, that is one of the big issues with machine learning, that it is more or less a black box. We can put in all this data, and what a machine learning model does is it tries to generalize it, figures out what are the features that I should use to determine a certain output, but we can't really see which ones the machine learning model is taking to create a certain output, and that makes it unpredictable and just a black box, and in certain cases dangerous if we give it too much power. But there's another story, and this is a story from 2011. It's a very interesting story. So what happened was in the city of Boston in 2011, they had a problem. And they had too many potholes on the street. And they did what everyone did in 2011. They built an app. And this particular app worked in a way that you could install it on your smartphone. And you could then, when you were driving in your car, you could put it on your passenger seat. And when this app is running, it picks up the vibrations. And if there's a pothole, it realizes, hey, there was a strong vibration. There is probably a pothole. And it then uses the GPS coordinates to map, hey, this pothole was here in this area. And is then sending that to some central server of the city of Boston, so that they can then go to that particular GPS coordinate and fix the pothole. In theory, that sounds like a pretty good idea, but the data showed that all the potholes were located in rich people areas. Only in neighborhoods with a high cost of living were potholes, which, if you think about it, doesn't make any sense, right? Why would there only be potholes in high cost of living areas? And the thing that the developers didn't think of in the first place, it was 2011. Not everyone had a smartphone where you could install apps on. Smartphones were not as ubiquitous as today. Nowadays, every 5-year-old is watching TikTok videos on their Galaxy phone, right? 2011 was a different time. So the situation in 2011 was only rich people had smartphones, only rich people had the app, and that basically skewed the data. Like you didn't get data from the other areas in the city. They later fixed that, and I think it's also a quite smart idea. They just put the app on phones and put the phones into public buses and garbage trucks, and basically vehicles that cover the whole area of the city. But the interesting thing is here, when we talk about AI and machine learning failing, this solution had no machine learning whatsoever. The problem here was simply that the data was biased, right? The data was wrong. The data was skewed because the source of the data was only a subset of the whole population of the city, and therefore it misrepresented the actual situation. And there is a particularly interesting example that we could all try at home. There are a couple of languages in this world where the pronouns are gender neutral. In German, it is he and she, and you can get, if it's he, that's male. If it's she, it is female. In Turkish or in Malay is the example that I've chosen here. In Malay, that is not the case. And if you use Google Translate again, and we have seen in the beginning how excited I was, right? That it like picks up my voice and can translate that. It's still failing. Like if you look at the example here on top, I have inserted she is a doctor and he is a nurse, which translates to the text on the right, which I'm not even trying to pronounce. But if we then use this exact outcome and translate it from Malay back to English, all of a sudden the translation is he is a doctor and she is a nurse. Now, why does it happen? And some people of you might remember that there was a couple of years ago when this first became public. It was with the Turkish language. The reason why this is happening is, again, because the data is broken, right? The data is skewed. If you think about how these machine learning model for Google Translate or the other translation services, if you will, are being developed, it's basically reading lots of text, right? It has like a long text in English and a long text in this case Malay, and then it's basically learning, okay, this word translates to this word and this word translates to this word. And the problem with historical data that we have when we talk about this text is that historically most of the doctors were male and most of the nurses were female. I mean, nowadays, obviously, in the world today, we know that independent of your gender, you can become a doctor and you can become a nurse, right? But historically speaking, this data translated this sentence that he or she is a doctor always to he is a doctor. And that's another example where even though there is machine learning model, there's machine learning involved, the machine learning is not the issue here. The data is what's broken and which causes this failure. A couple of years ago, when it became public that this issue existed in Turkish, Google then added this particular one feature where it would provide both of the main gender pronouns as a translation, where this translates to she or he as a doctor because they could simply not know. There's another example where some of you might remember this, where data had a severe impact on the outcome of a machine learning model. If you remember Tay, there was this Microsoft chatbot that they put on Twitter. And the idea was, hey, this machine learning model is more or less empty. It knows basically how to speak, but it doesn't know what it's talking about, right? It's able to pick up language and replay it back, basically picking up tweets, reading tweets, and then playing that back. And within 24 hours, Microsoft shut down this Twitter account. And the reason was that, and I may ask you, if you want a machine learning model to learn how to communicate with people, do you think listening to people on the internet is a good idea to learn how to actually communicate. Obviously not. The tweets that were addressed to this machine learning model were racist and sexist. And since that was most of the information that this model got, it basically developed a knowledge base, particularly based on hate speech. So I have a couple of examples here. You can look that up. They are pretty disgusting things. I think one thing where it's actually true, where Trey said the truth is that someone calls out, "You're just a stupid machine," and the response is that I only learned from you and you are dumb. I think that is another example where the data that you feed into a machine learning model defines the outcome, and if the data is wrong, then you just have a shitty outcome. Right, well, that's a chatbot, and it doesn't have too much influence on the world, maybe. There are, however, also systems that have way much more power than this, and the Compass system, which is a system used in the US, which is basically a system that determines jail time and the amount of bail that the criminal has to pay. And how this works is that criminals are being asked a large set of questions, like 200 questions, and based on the answers of that, this system predicts whether they are going to commit a crime again or not. And when it is particularly likely that a person commits a crime again, the bail and the jail time will be higher. Now, ProPublica analyzed this and the predictions and the outcome of this for a couple of thousand cases, and what they found is, and this is very interesting, they found that people who were labeled a higher risk of committing a crime again, but then did not do it, like they were falsely labeled a higher risk, that applied to 23% of white people. But it applied to almost 45% of African Americans. At the same time, people were actually labeled a lower risk, but then did recommit a crime. That was the case for almost 50% of the white people, but only 28% of African Americans. And the really interesting thing here is, so first of all, to understand that, clearly there was a racial bias in this system, right? If you are African American, you are more likely to be falsely accused of a higher risk than a white person. And on the other side, if you're a white person, you are way more likely to get away and are labeled lower risk, even though you will commit a crime again. But the very interesting thing to note here is that none of the questionnaire mentioned race or asked for racial data. No one asked, are you white or are you African American? It was data about neighborhoods that you live in and you have lived in the past, and a couple of other questions. And based on these quasi-identifiers, the machine learning model developed this racial tendencies. And there's another example, and as if the last one wasn't bad enough, there's a study that found out that autonomous driving cars are less likely to identify dark-skinned pedestrians. So basically, you use autonomous driving car, and it obviously tries to not kill people, right? So it looks at pedestrians. Okay, if there's a pedestrian, I can't drive. If you are dark-skinned, you are less likely to be identified, and you are more likely to be run over. And clearly, we can see why that happened. The data that was used to train this particular machine learning model to identify pedestrians was not particularly well trained with dark-skinned imagery, with imagery of dark-skinned pedestrians. In summary, the machine learning model can only follow the data that you put in, and I think that's where as I've said that a couple of times now, that's where the second issue with these data-intensive or machine learning applications are. So now you're looking at me and say, "Hey, Aiko, machine learning is everywhere. We have AI. Everyone's talking about AI. Every system is full of AI. And now you're telling me it's horrible and it sucks. Are we all doomed? And luckily, I can say we are not. There is a movement in the artificial intelligence or in the machine learning community to get explainability as a first-class model selection criteria. And that means that the first issue that we saw, where machine learning models are basically black boxes, we need to break that up, right? We need to try to understand what is going on. And I have an example here for image recognition. Is most likely to be used convolutional neural networks. And there are ways to visualize what is going on in these networks at a certain level. What do they identify? You can see here on the bottom, the initial layer just gets pixels, right? And then the further you go, the more pronounced get the predictions. And you can see, okay, so this layer is identifying eyes, and then later you see, okay, because it identified this eye and this facial structure, this is why it predicted George Washington in this case. To put it a little bit differently, we need to move away from the standard machine learning approach where we just have data and then our machine learning model gives us predictions into we need to add interpretability to it. We need the human inspections, and we need to see why a model has decided in a certain way. Another thing which has been really useful to understand machine learning and to have an idea of why decisions were being made is LIME. And this is local interpretable model agnostic explanations. And what that means is, or how this works, is it's a technology, a tool that more or less throws away random bits of the data and then see how accurate the prediction still is. So I have this visualization here that explains it rather nice, I think. We have this image of a tree fork, and the machine learning model predicted that it is a tree fork with 45% accuracy, right? Or like 40% certainty it's a tree fork. What LIME does is it removes, and that you can see here in the middle, in the top of the middle picture, it removes data points and see how accurate the prediction still is, how much it still predicts the same outcome. And you can see that if we remove the background and we remove like the part of the heart and the body, but we still keep like the frosh head and the frosh eyes, we still have we have an 85% accuracy, or 85% value that this is a tree fork indeed. If you, however, remove the frog head, then there's more or less 0%. So what it in summary does, it throws away data and see, is this data relevant? Because if it throws away data and still the outcome is the same, then obviously that data was not relevant. And that's a very nice way to identify what was relevant for a certain prediction and not. Another thing is, and we have seen how underrepresented people or underrepresented data for people or certain groups or subsets of a data set can cause relatively big harm. We need more diversity in teams, right? If, let's think about the example with the autonomous driving cars, if we would have had a more diverse team, we would have probably caught these issues early on and would have noticed, hey, okay, that doesn't work. Half the team doesn't get recognized as pedestrians. There's another thing that I really like, which is the data ethics canvas, which is if you ever are going to build some artificial intelligence system or machine learning system, you can refer to that, which is basically a set of questions that you ask yourself before starting a machine learning system, before building it. And the questions are, hey, who has access to this data? Who I'm sharing with? What are the limitations? And it tries to help you figure out where the limitations of your data are and what you can do against it. Another thing is remove data, right? If you don't need racial information, you can't always remove it because we've seen the pseudo identifiers. But if you don't need racial information, don't feed it into your system, right? It's only going to mess it up. And there are some other tools where one of them is Google Facets, which visualizes your data, which makes it for a human, for an engineer, easy to understand what is the data set that I have here. And you can just throw in the data, and you can then visualize, oh, look, 80% is male, 20% is female. I clearly have underrepresented females in my data set, and therefore I need to address that a little bit. On a similar note, there's this what if tool, which plays well with the Google Facets, which lets you compare multiple models with the same workflow, and basically visualizes, even with minimal coding, what is going on. Right. I hope I could give you some idea of the problems that we have with the current machine learning and artificial intelligence landscape, based on how machine learning models work, because since they're basically a black box, we don't know why things happen, as well as that the data that we feed into is often biased, more or less because our world is biased. The issue becomes big when we largely deploy these models, right? We have, if 1-2 people have this bias, it's probably okay. If all of a sudden this machine learning model gets applied to everyone and everyone is suffering from that bias, then the problem becomes significantly bigger. That being said, thank you very much for your attention, and let me know what your questions are.
Okay, Aiko. Let's see. We don't have any comments yet. Let's wait some minutes if there's any question. And yeah, while we wait, I will thank you for your presentation. It was very enjoyable. I see that you put a lot of effort on it, a lot of investigation on it, because there is a lot of mixed examples, and I think that will be very helpful for our community. There is even a group in Guatemala named Artificial Intelligence Guatemala, and yeah, there is some talk, and I think I will share this with them. Now it will be very helpful for them.
Yeah, cool. Yeah, I think one of the main ideas and my main motivation is, and I also think that one of the best approaches to solve this is for people to be aware of these issues, right? For people to be aware of these biases. For the last couple of years, there has been some kind of movement where the machine learning community has put effort into analyzing these biases. But I think and there are a couple of tools as I've showed. But I think the most important part is understanding that there is a bias and that we need to actively address that. Yeah, and it would be great if you can share that, and maybe you can erect some contact.
Yeah, for example, I think most of the things or most of the investigation has made in the artificial intelligence in the last years, even in Guatemala, is made on people, analyzing data from people, analyzing the crowd itself. What will be your recommendation for people that have starting to training models that works with data taken for people, like in a country from Guatemala or Latin America? What would be your recommendation for them and to take in account in their studies or in their models, actually?
Yeah, I think there are a couple of these things that I mentioned are quite helpful, and there will probably be more in the future. But I think the first thing that I would recommend doing is following this. Maybe I can go back to that slide actually. Following this data ethics canvas, which is just a set of questions, but having these questions laid out for you, and you actually need to think about it and need to ask yourself, hey, am I doing the right thing here? Am I creating a data set or am I using a data set that can rightfully represent everyone? and am I sharing it with the right people, and am I doing the right thing here? I think that is the first approach. And then regarding the bias in the data and the understanding of the machine learning model, the other technologies mentioned, I think, can be quite helpful. But then I think the main point is, if you already watched this presentation, you're already on the right track, because you're already aware that there's something that you need to do. And you can obviously do your own research. I mean, I only had 30 minutes. There's significantly more out there. And I think having the understanding that there is an issue that we need to address is the first step in the right direction.
Yeah, nice. There is one comment from Luis Dorat, and I think he will translate all the feel that from the community. He says, "Thank you so much for letting us know how developers can keep AI kind of ethically human." So there's a lot of things that you need to take care in the training models and something like that you mentioned. There is some discrimination, that bias on the models that is everywhere. And don't put 100% trust on that system. There's always an error.
Yeah, that is very true. I think we've had this issues before, right? We all are full of bias, whether we know it or not. With the large scale distribution of machine learning models, the issue that comes is that everyone can be affected very quickly, right? We can deploy a model to a billion people with the click of a button nowadays, and that is where we need to be just more cautious about what we are actually doing.
Thank you, Aiko. There's one more question from the comment section, and I have a personal question after that question. It says, what can you recommend me how to start with artificial intelligence? Are there some programs or courses about this content?
Absolutely. The internet is full of learning opportunities for artificial intelligence. There are, I think one of the most famous one is a Coursera course I think developed by Stanford and Google machine learning or artificial intelligence experts. I think that is mostly free. There are a vast amount of courses and resources online.
Nice. And I'm gonna recall when we were in backstage before starting this presentation, and you were telling me that you actually work not on AI, but work on like in the platform development, right? And my question is, have you seen in your research any implementation of AI like in that kind of world? Like, do you think there is a future in AI or an opportunity in AI in developing platforms, for example, I don't know, in the cloud or Kubernetes? I don't know.
That's a very good question. I think I mentioned how, and you all know it, right? How hyped AI and machine learning has become over the last couple of years. And I think there are already a couple of domains where AI and machine learning has been establishing itself. I think it will definitely grow. Like if I mentioned all these learning opportunities, a lot of people learn about that. If I look at my LinkedIn, half my people are machine learning engineers now, half my connections. I think there is a lot of stuff going on, a lot of people who are interested, and there are a lot of companies figuring out, okay, there is something that I can do in my domain that previously nobody thought about. In particular, in platform engineering, I have not implemented anything with machine learning in that regard, but I can assume, like, if you think about highly available systems, or if you think about the mean time to recovery, if you think of predicting load on your system, there are probably ways how you can implement some machine learning models that help you build the correct system, because it kind of helps you. Okay, these are the actual requirements. This is the prediction is that you need to support these and these many users or load. I think there are opportunities. I think over the next decade or decades, most of the domains will have found some kind of use case for this kind of technology.
Nice. Yeah, because I wouldn't be surprised, like in a couple of years or months, to read something like AI ops, because everything now it's ops.
Yeah, right.
So,
yeah.
yeah.
Okay, so I think that's it with the questions. There's just one last question. Which text or book would you recommend to taking care for the entire system?
There is one book that I think is freely available online. Let me quickly check that. I think it's the neural network book. It's neural networks and deeplearning.com, which is a full book. It sounds like it's particularly specific to deep learning, but it's not. It's a full book that that you can read through. It's freely available. Yeah, so that can be found under neural networks and deeplearning.com. So that is something that helped me a lot.
Neural networks and deeplearning.com. Okay. Nice. I will take care to share that with the communities, and I think we can close now. And saying thank you to you for being with us, sharing your knowledge, sharing your investigation with us, and I think it will be very helpful for our community. And yeah, thank you for being here.
Yeah, thank you very much for having me.
Yeah, and so thank you so much to the community. And our next session is tomorrow at 9:50 a.m. So it will be the future of database. This is a keynote session by Steve Jones. So don't miss it. And yeah, follow us in our social communities.
Thank
See you guys.
Aiko. See you later and see you tomorrow, guys.